So when we add and subtract fractions, the very first thing we need to do is figure out what our common denominator is. And we want to try to use as small a number as possible so that we have less to simplify in the end. However, my common denominator cannot be any smaller than the largest of the two denominators. So if I'm looking at question number 1, what is my larger of the two denominators? 27, right? So I have to use at least 27, if not something bigger. So the first thing I want to ask you is 27 is my bigger denominator. Does 18 divide into 27 evenly?
No.
No, it doesn't. Okay. So then what I have to do is figure out what is the next thing that both 27 and 18 can go into. So what I said is, what is 27 twice? 54. Does 18 go into 54? Check your calculator. 54 divided by 18. Does that go in?
No.
You can even try it in the calculator. It does go in 3 times, doesn't it? Okay. So our common denominator is going to be 54. So the next step is to rewrite both of my fractions, with the same denominator. So I'm going to use 54. And if I'm changing the denominator, I have to change the numerator by exactly the same thing. So starting with the first fraction, what is it that I multiplied 18 by to get 54? 3. So I have to do the same thing to the numerator. So I'm going to multiply 5 times 3, which is going to give me 15. Okay, so my new fraction becomes 15 over 54. And then with that second fraction, what do I multiply 27 by to get 54? 2. So I'm going to multiply the same thing at the top. And 2 times 2 gives me 4. That's the first goal, is to get the same denominator for both of your fractions. I found what number can they both divide into. Yeah. All right, so then what I can do is I do what it actually tells me to, this numerator minus that numerator. So we're going to write it as one fraction, 15 minus 4, and it is over my common denominator of 54. And then can I actually do 15 minus 4? Yes, what is 15 minus 4? 11. Mm-hmm. Huh? That works as long as you know how to use your tool. When I do this, the next thing I want to check is, can I factor anything? Well, I just have one number over another, so nothing is going to factor. The last thing I want to check is, can I simplify? Do 11 and 54 have anything in common? No, they don't. So we're going to leave our answer just like that. And yes, because that question had absolutely no variables in it, you could have just done it in the calculator. You could have done 5/18 minus 2 over 27, and it would tell you 11 over 54. Or it should if you use your calculator correctly. Uh-huh. The 2 at the top? Oh, because I asked myself, what did I multiply 27 by to get 54? Whatever I multiply the bottom by, I have to multiply the top by. Does that make sense? Okay. All right, write down number 2. Go ahead and start working on figuring out what you think the common denominator should be here. I have x over 4 plus 3x over 8. Now, obviously, these have variables in them, so the calculator is not going to do all the work for me. But what I do need to do is look at my 2 denominators. I want to figure out what is my common denominator. I want to use the smallest I can so that I have less to simplify in the end. The way that we do that is you look at your larger denominator. What is your larger denominator here? 8. And then ask yourself, does the other denominator 4 actually divide into 8? Yes, it does. So what would we want to use as our common denominator? 8. So we are going to now rewrite both of our fractions as something over 8. Go ahead. Because I have to multiply top and bottom by what to get 8? 2. Yep, so we're going to multiply the top by 2, which gives me 2x. Do I need to change that second fraction? No, it already has an 8, so that numerator is going to stay the same. And now that my denominators are the same, I can just do what it tells me to. The first numerator plus the second numerator over 8. Can I actually combine 2x and 3x? How much is that going to give me? Can anything factor? No, it's just one term over another. Does anything simplify? No. Yes, ma'am.
Would you mark us if we did like 8 times 2 and 4 times 4 to get 16?
No, you just need to make sure you simplify all the way in the end. That would work. Anybody have any questions? All right. I would like for you to try 3 and 4. My denominators are 7 and 4. Looking at that larger denominator of 7. Does 4 go into 7 evenly? No, but what number can both 4 and 7 divide into evenly? 28. Okay. So I'm going to rewrite both of my fractions. Starting with the first one, what do I multiply 7 by to turn it to 28? 4. So that means I'm going to have to multiply that numerator by 4 as well. What is 2y times 4? 8y. And then the second fraction, what do I multiply 4 by to turn it to 28? 7. So I'm going to multiply that top part by 7 as well. What is 3x times 7? Okay. Now that my denominators are the same, I'm going to take that first numerator, 8y, minus the second numerator, 21x, and put that over 28. First question, can I combine the two terms at the top of there? Okay, one's an x, one's a y. The next thing we want to look for is, because I do have two terms at the top, what I want to ask is, do those two terms have anything in common? Do 8y and 21x have anything in common? If those two don't have anything in common, then there's nothing else you can do to simplify any part of this problem, and we leave it just like that. Okay, you cannot just simplify 2 of them. All of them have to be able to simplify. Is that one okay with everybody? All right. Now 4 is slightly different because it does involve a variable. In order to have a common denominator, because one denominator has a variable in it, your common denominator is also going to have a variable in it. So let's think about the numerical parts of it only. Between 2 and 4, what is a common denominator for 2 and 4? 4, okay. But we also have to include that b, and so it's just going to be 4 times b. Like, do you see how here, to get our common denominator, didn't we essentially just multiply those two? Yeah. Okay, that's what we have to do. We have to include the parts, the variables, by multiplying. Does that make a little bit of sense? Okay. What is it that I'm going to have to do to 2b to make it look like 4b? Multiply by 2. Okay, so just 2. I don't need the b. I already have the b. And so 5 times 2 is going to give me 10. And then for the second fraction, what do I multiply 4 by to turn it into 4b? 4b. Just b, right? Yeah. So at the top, 3 times b is going to give me 3b. For
the other one, for number 3, can we not simplify the 8y and then...
No, all of them have to be able to simplify. The 8y, the 21x, and the 28 would all 3 have to simplify. All right, now that I have the same denominator, I'm going to take that first numerator minus my second numerator and keep it over that denominator. Can I combine 10 minus 3b? No. Do 10 minus 3b have anything in common that I can pull out? No, which means nothing in this problem can simplify. If those top 2 terms do not have anything in common, there's nothing else you can do to that question. That makes a little bit of sense. Okay, try these 2. And there is definitely going to be a question like 6 on your test, so we want to make sure we get through that when we get to that point. Starting with question 5, my denominators are 10 and 5. Bless you. My bigger denominator is 10. Does 5 divide into 10? Yes, so I'm just going to use that as my common denominator. Do I have to actually change the first fraction? No. Okay, so that numerator is not going to change either. What do I multiply 5 by to turn it to 10? 2, and 3 times 2 gives me 6. So when I do this, to write it as one fraction, that first numerator stays the same. Then it is going to be minus the second numerator, which in this case is just a 6. And all of that is over 10. However, can I keep going on this one? Yes, there are some terms that I can combine. That 2y I cannot combine, but the positive 3 and a negative 6 together give me negative 3. And then I want to check that numerator because I have two terms. Do 2y and 3 have anything in common? No. If those two don't have anything in common, there is nothing else you can do and you leave your answer just like that. Which is what I saw on most everybody's paper. Now, with number 6, first of all, in order to add fractions, don't I need 2 fractions? So how do I turn 7 into a fraction? Put it over 1. Okay. So one of my denominators is 1. One of my denominators is x. So what would my common denominator be? 1x, yeah. Or just x, which means the same thing. Okay. First fraction. What do I multiply 1 by to turn it to x? X. So I have to do that at the top as well. So what is 7 times x?
7.
Okay. Does the second fraction change? No. So right now I have 7x over x plus 1 over x. And so I need to actually add those together. The first numerator, 7x, plus the second numerator of 1 over x. Can I combine 7x and 1? No. Do they have anything in common that I can pull out? No, which means nothing can simplify. And I'm going to leave my answer just like that. Again, I give a question very similar to this on this test every year, and every year I get some funky answers for this one. Okay? This is not meant to be a hard question. But I get 8, or I get 8x, or I get 9, or I get just a bunch of weird answers. Okay? This one's not hard, but you will definitely have one like this on your test. Ready? Yes, ma'am? Yes. All right, I want you to do 7. Hold off on 8 because this one is... All right, so we're going to use the common denominator of 8. Does the first fraction change? No. What do I multiply 4 by to get 8? 2. Now, here's the key. How many parts are in that numerator? 2, the x and the 1, right? So when we multiply, we need to first of all make sure we multiply both of those. So that would give me a 2x plus 2 there. Okay, so that's the first thing you need to make sure you do. Now that we have the same denominator, I can take and I can add the first numerator, x minus 2, plus the second numerator, 2x plus 2. All of that is going to be over 8. But I have some terms I can combine, right? Start with your x's. I have a 1x plus a 2x. What's that going to give me? 3x. And when I combine that negative 2 and that positive 2, what do they actually do? Cancel out. So it's going to be 3x over 8. Can that simplify at all? No. Now 8 is different. Go ahead and decide what your common denominator is. And then rewrite your fractions and then hold there for a second. Because this one is slightly different. We need to make sure we're very careful with it. 1x plus 2x. Oh. So do you see where I have the, you have the 1x right here? Plus 2x. So 1x plus 2x gives you 3x. And then that negative and that positive 2 actually just cancel each other out. And so then it's just that's 8. That makes sense? What is my common denominator going to be for number 8? 9. So first fraction, what do I have to multiply the top by? 3. So that's going to give me 3x. I don't have to change that second fraction. Now here's why this one is different, and you need to be very careful with this. We have done other subtraction problems. However, in all of those other subtraction problems, the fraction that is behind the subtraction only had one term in the top. How many terms in the top of that second fraction? 2. And when I subtract, I have to make sure that I subtract both of them, okay? So what I would recommend doing is when you have a subtraction and multiple terms in that second fraction, I would put those in parentheses before I try to solve this so that you don't forget that, hey, I need to make sure I'm subtracting that x and that 1. Does that make a little bit of sense? Because I'm subtracting both parts of that numerator. Every other fraction we've done so far, it has just been one term. So what I would want to do then is keep that 3x, and I want to distribute that negative to that x and also to that 1. Okay, making it a -1, not a +1. If you have it as a +1, you have the wrong answer. What terms can I combine at the top there? The 3x minus 1x, what is that going to give me? 2x. So my final answer is 2x minus 1 over 9 because 2x and 1 have nothing in common. If you have a +1, that is the wrong answer. You have to make sure that when you have subtraction problems, if there are multiple pieces in the top, you have to subtract them both. You're right, because the fraction up here started as x plus 1, but we have to subtract. So when you subtract a positive, it's like a minus.
So would it be like 2 or 4?
Yeah, I'm not distributing the 3x here. I'm not distributing that. I'm just distributing this -1, which makes that a -1x and a -1 there. Because it's the 3x minus. Does that make sense? Is everybody okay with that? Yeah. All right, number 9 is very similar. I want you to try this. This is our last one. All right, my two denominators are 6 and 2. What would my common denominator be? 6. Do I have to change the first fraction? No. But with the second fraction, I have to multiply 2 by 3. Okay, so I'm going to take that and multiply that 3 by both the y and the 2. So that would give me 3y plus 6 at the top. So what I'm going to do now is write it as one fraction. This first numerator, 5y, minus, but because I have multiple parts in this top one, I'm going to put them in parentheses. Okay, and all of that is over 6. So all I did was I took that first numerator minus, and I put that second numerator in parentheses. Now I need to keep going because I need to simplify. I'm going to keep that 5y. If I distribute that negative, that makes that a minus 3y. And what kind of 6? A -6. Are there any terms that I can combine? Yeah, which is going to give me how much? So far, so good? Yeah. All right, now the same question I've been asking all along, and we haven't been able to do that yet. Do 2y and 6 have anything in common? What can I pull out? A 2. So if I do that, that leaves me with y minus 3, correct? And by doing that, do you see that I have the 2 being multiplied by the y minus 3 and the 6 at the bottom? So therefore, what can I do with that 2 and that 6? I can divide them both by 2, right? So I end up with just y minus 3 over 3? Yes. No. The key is you just have to remember that they can only simplify if all 3 simplify. The issue is to